Today we are going to wrap up Unit 5. We're going to look at the last method to prove two triangles are congruent, and then we are going to talk about what we can do with those triangles once we've proven them congruent. So let's go ahead and look at our last method. It's called Hypotenuse Leg Theorem, and we abbreviate this one HL. All right, remember when you're dealing with a right triangle that the side opposite the right angle, that's the hypotenuse. And then the two sides that create the right angle are the legs. So what this theorem tells us is that we need the hypotenuse of a right triangle and one of the legs. And I've told you that you always need three items, and in this case the third item is that it's a right triangle, so you have to have a right angle. So technically we do have three, but we don't list the third one. So let's draw a couple pictures. So here we've got triangle ABC, and triangle DEF. And to use hypotenuse leg, they have to be right triangles. We have to know that before we start, or we have to be able to prove that they are right triangles. So hypotenuse leg, we have to know that BC and FE are congruent because those are the hypotenuses. And so other than that, we either need AC is congruent to DF, or we need AB is congruent to DE. We don't need both of those. We need one or the other. Either way will prove that triangle ABC is congruent to triangle DEF by the hypotenuse leg, or by HL. Just as a bonus method, some teachers teach this as a separate method. Here we have right triangles where the legs are congruent. So we have two pairs of legs, and some people teach this as leg-leg theorem, but it's really just side angle side, because here's a side, the right angles are angles that are congruent, and then we have another side. So if you ever see leg-leg, it's really the same thing as side angle side, so we don't cover it separately. So let's look at a couple of these and see if we can use HL or anything else to prove them. For 1A, we see that they share a side. We know that they are right triangles because we've got that perpendicular box. And since they're right triangles, okay, the sides with the two congruent marks, those are hypotenuses. So I'm just going to label both of those L's. The side that they, or excuse me, both of those are H's. The side that they share is a leg. So yes, we can use hypotenuse leg theorem there. For B, we see that these are right triangles, but we don't have any sides. Remember, you have to have at least one side to prove congruent triangles. So without a side, we know that they cannot be proven congruent. And for C, we've got our right angles. We know they're both right triangles. Okay, we know that we have the hypotenuses as congruent. And just like in A, they share a side, so that's a leg. Our blue ones are hypotenuses. So yes, we can use hypotenuse leg. All right, let's do our proof of how we could use show this in a proof. We know angle Y and angle E are right angles. We know that HY is congruent to EL, and we know that HP is congruent to LG. and our reason is given. Let's go ahead and mark all of that stuff in our picture. Okay, our right angles are already marked. I'm going to do it again just so it stands out a little bit more. We are shown that HY and LE or EL are congruent. And we know that HP and LG are congruent. So we've got right triangles. We've got the hypotenuses for them, and we've got a leg. So we have enough information. Here's the part that's really annoying about hypotenuse leg. In order to use it in a proof, we have to have an extra statement first. We have to say triangle HYP and triangle LEG are right triangles. We have to have said they're right triangles before we can use HL theorem, and that's just definition of a right triangle, a triangle with a right angle. Now we can say that they are congruent by the HL theorem. So it's annoying, but in order to use HL, you have to have stated that you have a right triangle. Okay, now, once we've proven two triangles are congruent, then we can pull out any two pieces of those two triangles that correspond to each other, and we know all the pieces are also congruent. So there are 6 congruency statements we can make about the pieces once we know the triangles are congruent. So looking at triangle IHG and HIC, let's mark everything and then we'll write out some statements. So we know that angles I and H are congruent. Well, we don't have angles I and H, but we know this angle and this angle are congruent. They correspond to each other. The same thing with these two angles. They correspond to each other. And with C and G, they correspond to each other. And again, all that we know because of the order of the letters in our triangles. We also know that CH and IG correspond to each other. CI and HG correspond to each other. And HI corresponds to itself because they share that side. So we can go back through and write out all 6 of those statements. Angle CHI is congruent to angle GIH. Angle GHI is congruent to, actually I'm going to start with the left triangle every time. So angle CIH is congruent to angle GHI. Angle C is congruent to angle G. We only need one letter for those because there's only one angle at each of those points. We know segment CH is congruent to segment GI. We know segment CI is congruent to segment GH. And finally, we know that HI is congruent to itself. So based on our congruency statement for the triangles, we're able to make 6 different statements, and the reason for all of these is corresponding parts of congruent triangles are congruent, and we abbreviate that with CPCTC. Corresponding parts of congruent triangles are congruent. So let's run through one more proof for the day and then we'll be done. CR is congruent to TS and CR is parallel to TS. So they're congruent and parallel. Let's mark things. So they get hash mark and they get a triangle for their parallel. Now, to use our parallel part, let's, like we've done before, extend these and extend that diagonal just so we can see the parallel lines a little bit better. So now that we've got those extended, let's look at these two angles. We know they are congruent because they're alternate interior angles. So that's angle CRS and angle TSR. And again, those are alternate interior angles. So we use the alternate interior angle theorem. I'm going to erase my parallel line extensions and mark these two angles. Then we have this side that they share. So SR is congruent to SR, and that's by the reflexive property. And so now we have enough information using side angle side to say that triangle CRS is congruent to triangle TSR, but that's not what we wanted to prove. What we want to prove is that CS and RT are congruent. But now that we've shown the triangles are congruent, we can easily take one more step and show that the pieces are congruent, and our reason is CPCTC. So now you've learned every method to prove triangles are congruent: side, 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 angle, side, angle, side, angle, 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 side, and HL. Plus we've also learned what we can do, or the reason we would use once we've proven the triangles are congruent, to go back and find pieces of those triangles that are congruent. So make sure you do your practice, ask questions, do your best, and then get ready for that mastery check. Good luck.